Hello, everyone. How's it going? Excellent. Has everybody had lunch? Excellent. So hopefully no sleepy faces here after lunch. No, I'm just kidding. So this talk is about writing serverless apps, and maybe we can turn the sound off anyway, because I hear myself. All right, can everybody hear me in the back? If no? I have some yeses, some nos. So. All right. Let's turn it on. All right. Yeah. Yeah, let's just do it. All right, so I'm Kevin Dubois. I'm a developer advocate at Red Hat. And let's get right into it. So the good old days. The good old days of the monolithic application. We just developed our application, and then you throw it over the wall to ops, and they have to deal with scaling or dealing with deployment of the application and everything, right? And so at some point you have more traffic. You just ask them, hey, add some more resources, add some more CPU or memory or whatever, and then it's their problem. But so that's not really how we develop anymore. Well, mostly, right? So some people still do. These days we're doing more cloud development, right? Typically on Kubernetes, because it gives us a lot of advantages, and I'm sure you're all aware of what some of these advantages are. This is not so new anymore, but we have basically the advantages of being able to respond more quickly to demand. We can scale based on demand. We can do things like rolling deployments. We can do A/B testing. We can do blue-green deployments, canary deployments, shadow deployments, all that stuff, and we can have high availability, and we don't have downtime when we release. So there's some advantages definitely to cloud computing and cloud-native development, right? And then if we kind of go beyond that, because here we're talking mostly about containers and kind of classic Kubernetes deployments that don't necessarily scale exactly to demand, right? So there's still a little bit of a gap, and so that's where serverless, of course, comes into the picture, which again, I'm guessing most of you are familiar with. And basically the idea behind serverless being, on-demand scaling, so you only pay for what you're actually using. You're only using the resources, let's say the electricity even, that you're needing in that moment. And so you can be scaled and build based on demand. And of course, serverless, because there's no server management. That's kind of the promise, right? And so, yeah, of course, everybody, when they're talking about serverless, has to say something about, yeah, but there are still servers behind. So of course, then I have to add this. But so, yeah, the idea behind serverless essentially is, if you look on the left side where you're running a more classic way of deploying, you have to basically over-provision all the time in the case that you get a spike in traffic, right? So you always have to have more resources running than what you actually need, just in the case that you have a big spike of traffic. And then you can see, actually, there's such a big spike at some point that you're still under provisioned. So even though most of the time you're running too many resources for what you need, you still don't have enough for certain cases. And so serverless ideally can scale very quickly just based on that demand of the exact moment, and that's where it's really nice. So a use case from my company, so I work for Red Hat, right? And so we have this OpenShift sandbox, and so it's this free OpenShift instance that, if you go to developers.redhat.com, you can get this for free, an environment to test out, to play around with, deploy your application and whatever more. And so we've had this OpenShift sandbox for a while now. And the default deployment mode, if somebody would play around with it, was to deploy with a regular Kubernetes deployment. which means that, you know, if somebody is playing around, then they deploy something, that application is just running for 30 days, right? Because that's how long the sandbox runs, and then you have to create a new one. And so was using a lot of resources. So at some point, we changed it to use, OpenShift Serverless, which is basically Knative. And so the default deployment now is Knative Serverless, which means that when somebody deploys something, their application is going to run, and then after a while, it's going to scale down to 0 and just wait until you're using it or until traffic is going to it, and then it'll scale up. And so it's pretty cool because all of a sudden we have this big savings of money. And so you can see on the left side, that was the previous version running just with regular deployments, and so you got 7 gigs of RAM and 15 gigs of storage. And so now, because we have all the savings, we want to also kind of give back, I guess. And so now we can also increase the resources of these clusters to use more, more memory and RAM. So that's kind of a funny story and a true story, actually. So that's, the advantage, or one of the advantages of serverless. So, what does this all have to do with Java? Because the title was writing Java, serverless Java applications with Quarkus and Knative, right? So what about Java and serverless? Well, this slide is a little old. It's from 2018, as you can see here from the link. And they did this survey, and basically out of this survey came that only 6% of serverless workloads were using Java, and that kind of makes sense, which I'll go to in a little bit. But you can see here, this is a more recent survey from Datadog, and you can still see that Java, I guess it's increasing, but you see that Python and Node.js are definitely still the main languages used for serverless. So we're talking about serverless in terms of, it saves us resources and energy, and potentially saves us money, maybe even, makes our carbon footprint a little smaller. And so here's those 3 languages that I'm talking about. And so this is a research paper that came out about the efficiency of programming languages. Who's seen this already? Yeah, so because we like to talk about this in Java, right? Because you can see, Java is actually a very energy efficient language compared to those 2 languages that are very popular for serverless. And so it's like, well, I mean, JavaScript uses, at least double the amount of energy, and Python is what, like 30 times more or something, even more. So, like, why are we using those languages if we're trying to save resources and save energy, if that's our use case? So, why not use Java? Well, this is one of the main problems with it, right? I mean, traditional Java, we all know it's not the fastest to start up. It wasn't built for serverless. And even after it starts up, an application running on the JVM is still using some time to start up. It needs to warm up and optimize and everything. And at that point, it's still not using as much capability in terms of requests per second that it can use. So that's something that needs to be fixed. And fortunately, of course, there is a fix to that. Otherwise, I wouldn't be talking about it. But this is kind of the drawback of traditional Java in terms of serverless. It does not start up fast enough. And when you can't scale fast enough, you lose resources, you lose potentially customers, and we don't want that, of course. So if we look at the traditional Java, let's say traditional Java framework at the startup time, how it's actually working is you do your build, you do your Maven package or your Gradle or whatever, and then all that optimization that happens is during runtime. So you start up the application, and then it's going to load everything from the config files, class path scanning, and essentially build its model of the world, and then start management and everything. And that's all happening as the application is starting up. So that's not ideal with serverless, right? We want to immediately be able to accept requests and handle everything. So Quarkus, the way that it tries to fix this issue is by moving a lot of that stuff to the build time instead of during the startup. And that's how it's able to, of course, start up a lot faster. And then, you can use native compilation as well to, go even faster potentially. There's some drawbacks to native, of course, in terms of dynamic behavior, and we're not going to go into that too much because this is not a talk about native compilation, but, yeah. And if you've been to a Quarkus talk, I'm sure you've seen this slide before. Basically, showcasing that Quarkus uses a lot less memory and starts up a lot faster, right? And that's what we want for serverless. So serverless, Java, and Quarkus. So when we're talking about serverless, let's say initially serverless kind of was, well, it's function as a service, right? And so you would do like an Amazon Lambda or Azure Functions or one of those, and that's pretty cool. I mean, you can get up and running pretty quickly with that. You can you can create functions. There's some downsides to it in terms of there's typically a limited execution time. There's not really orchestration, but yeah, you can use Lambda pretty well. The downside is that this is an example that I got from AWS, from the Amazon documentation, and this is their example to create a Java function with Lambda. And you can see here all those dependencies for Amazon AWS, which means that you're writing an application with a lot of dependencies on this specific cloud provider, and it's the same with some of their competitors, right? So yeah, lock-in, yeah. We don't necessarily want lock-in. Well, some people are okay with it. They say, well, we're okay with Amazon. They're pretty cool. And yeah, sure, they're pretty cool. But what if one day you want to also take advantage of another cloud provider? Maybe you want to move some of the functions on-premise because you can use serverless on-premise as well. Well, you're basically going to be stuck rewriting everything, right? So that's not so ideal. And then, well, in addition to your function itself, usually it doesn't just run on its own. It uses, other components, which, again, those hyperscalers are like, yes, this is awesome, like even more lock-in. Yeah, so because maybe you need an S3 bucket, or you need to use some sort of gateway or use a database or something, and they're like, yeah, cool, come here, we got services for all that. So why not write cloud agnostic functions where we can write our functions in a way that we're not locked into one specific provider? And so that's where Quarkus is really cool. With the Funky project. Who's heard of Quarkus Funky? Daniel, wow, nice. So Funky is a really cool project because it allows you to, write functions, but not be tied into a specific provider, because you basically add an extension, for example, for AWS Lambda or for Google Cloud Functions or something. And so all that proprietary stuff is abstracted away in the extension. So you can write functions that have no kind of dependency directly on those cloud providers' libraries. They're still being used, just in the extension itself. So you can see here a very simple example of a function created with Quarkus func. So basically, you just add the func annotation, and the magic happens kind of after that, because you just add an extension. So you can see there, for example, Amazon Lambda or Google Cloud Functions, Knative as well. We'll see that in a little bit. Or you can just create a very kind of basic HTTP function as well. So let's try that real quick. Let's see if we can create a function. Let's close Slack. All right. So we're gonna go into this folder, and I'm gonna do Quarkus. We're gonna just create a new app. Create app, and we'll call it AWS app function. And I'm gonna add one extension, which is that AWS Lambda function. All right, so I think it's called funky Amazon Lambda. We'll see. Okay. So we created this new project with some starter code even. So if I go into this code, AWS function, let's take a look at this real quick. So we can see, oops, so my fingers are not cooperating. All right, so here we have our Java, and it created a greeting function, very basic, right? So basically, we got my func greeting person friend. So we can see here that this is the implementation, which is very simple. And so basically, it just returns hello friend. And so if we want to create this and push this to AWS Lambda, we can just do Maven package, and you'll see that because I have that extension for AWS Lambda in this case, we're going to create all the dependencies, and we'll have everything we need to deploy this to AWS Lambda. So if we look in our target here, we can see, if you're familiar with AWS Lambda, you need like the function zipped and then some of these properties. And so, you know, that's all we need to create this function on Lambda. And I don't need to use any of those dependencies. So then if I want to change, let's say I want to switch, or I want to also deploy with somebody else, all I'd have to do is just remove that extension, add the extension for the other cloud provider, and then we're up and running again, because I don't have anything specific for AWS functions. Now, there are some specific AWS capabilities when you write functions that you could add with a context to your function, but yeah, then you're, of course, a little bit locked in again. So it's better to try to keep your functions agnostic. So that's, you know, creating functions for, you know, different cloud providers with Quarkus. But so there's functions, but actually serverless is kind of evolving, right? So there's, of course, there's still functions as a service. You can use those. But cloud providers and Kubernetes itself with Knative allow you to create serverless not just from functions, but actually use containers. And actually that's a lot more interesting for a lot of use cases, because functions are a fairly limited use case. So you can use containers that scale down to 0 and that can scale based on requests, instead of your typical Kubernetes resources that scale based on CPU and memory, where you actually have to have a pod that generate these metrics to be able to scale, right? And so the idea behind serverless containers is that it's based on requests, where you're actually scaling based on the actual usage in that moment, and you have control over how fast and when to scale. So serverless containers has a lot more use cases. Of course, there's a little bit more overhead, because now you need to worry about, how are you going to build your container? Whereas with functions, the idea is that you just have your function and you push that to your to whatever is orchestrating your functions. So serverless containers. So you have AWS, they have Fargate, you have Azure with their cloud function, you have Google with their Cloud Run, you have container instances with Azure. And so you can use those, but this time, because I don't want to just kind of say things about AWS, I'm trying to be a little spread the joy, I guess. So in this case, I got some documentation from the Azure website, and so this is for their Azure container instances. and you can see, you know, some reference architecture, and, you know, conveniently enough, you can see here too, well, you can use these containers in a serverless way, but again, you have other dependencies to be able to actually use these containers, right? You need some sort of orchestration or some messaging system, some database or something, and here we go again, locked in again, right? So that's not ideal in my opinion. I don't like lock-in too much. I like to keep my options open. And so that's where the project Knative comes in. So Knative is basically a project that allows you to use serverless using Kubernetes, so open source projects, Cloud Native Computing Foundation backed projects, to be able to use serverless, and not just serverless, but, you know, all the ecosystem of Kubernetes, where you're not necessarily tied to a specific cloud provider. And so with Knative, you can create functions as well. So you can do kn-func create, and then specify the language. So in this case, you know, I of course did Quarkus, and then you can create your function, and then you can push your function, basically kn-func deploy, and then it'll push your function to a Kubernetes cluster. So that's pretty cool that Knative can do that. You can create a function that supports Knative as well with Quarkus, so you can just do Quarkus create app, and then instead of using the funky Amazon blah blah blah, you can use funky Knative cloud event or funky HTTP. Or you can use Knative also for more than just functions, of course. You can create containers with Knative as well. So you can do Knative service create, some name of your service, supply an image that you've built and ideally push somewhere, and then Knative will take care of creating the kind of the deployment, the service, exposing your service that you would in Kubernetes need to, you know, do kind of in 3 different steps, right? Because you need, you know, a deployment or some sort of replica set or something, and then create a service, and then some ingress or route or something. And so Knative does that all kind of automatically. So, you know, in that serverless spirit of we don't care about, you know, like configuring servers and managing servers. So Knative can do that as well. So that's pretty cool. So Knative can do some more stuff. So first of all, of course, it makes containers easy, like I showed, you know, so you can create and push containers pretty easily. So with the Knative funky, or func at least, you can create projects and push them as containers. You can manage containers as serverless workloads. It also has this idea of revisions. So every time you push a new version, a new change in your configuration, a new image or something is going to create a new revision, which means that now, just like in, you know, like Git or whatever, you can revert to your previous revision, or you can, you know, deploy 2 different revisions at the same time. You can split your traffic, you can do rolling deployments and everything. And so that you can do with Knative out of the box as well. Of course, you know, it's serverless, so automatic scaling is, you know, kind of out of the box as well. So you can scale based on requests, and you can configure that, right? You can say, hey, for each concurrent request, create me a new pod, which is very aggressive, of course. Or you can say, you know, every X amount of requests, you know, scale automatically. If there's no request coming in, scale down to 0 or not. You can also say, I want a minimum availability of X amount of pods so that there's always something that's that's warm. And, you know, so Knative is basically hybrid cloud, right? Because you use it on Kubernetes, that means that you can run it on-prem, you can use it on any of the cloud providers, you know, kind of interchangeably, which is pretty cool. And then, of course, because it's using containers, you can use any programming language. So, you know, for sure, Java and Quarkus, but also, you know, anything that you can run in a container, you can run with Knative in a serverless way. And then it supports also event-driven architectures. So it has an eventing component to it, which also make even more use cases possible. So we talked about, creating functions, we talked about, serverless containers, and so really the next step in serverless is eventing, is integration and state, and being able to use serverless even for those use cases, because that's where it actually makes the most sense, is with events, because we have events coming in. We want to scale based on what events are happening, right? That's really where it shines. And so being able to tie that all together is what Knative allows you to do. So Knative, on the one hand, has the serving capabilities, so to scale from 0 to whatever, has the revisions, automatically exposes your ingress, your routes, and on the other hand has an eventing component too. So the Knative eventing uses the cloud event specification to build event-driven, let's say sort of like an event mesh for your application. So you can say, hey, when there's an event happening, somebody dropped an image in my S3 bucket, or an application is sending some sort of an event, or there's a merge request that happened in Git or something, and that's going to create an event that's going to be sent to some sort of Knative broker, or you can send it directly to your application, of course, and that's going to trigger the application to scale up if it needs to, or just handle the event through using standard API events using cloud events. So cloud events is a specification that is governed by the CNCF, by the Cloud Native Computing Foundation, to have a standard for how events should be formatted. And so this allows different types of applications, different kind of protocols to be abstracted away from your application. So instead of having your application having specific knowledge of, I want to use, for example, Kafka. So in my application, I build all the dependencies on Kafka. And then at one point, hey, there's this other technology that we want to use. Okay, now we have to rewrite everything again because we have the Kafka dependencies. So what you can do with cloud events is you can say, hey, instead of my application having knowledge of the protocols or whatever that this message is going to use, I'm just going to create a cloud event, and then I'm going to let's say, middleware, which that's kind of an old name, right? But so whatever's in the middle, handle whatever protocols it needs to use, whatever technology it needs to use. So for example, you can send a cloud event, send it through a Knative channel, which is backed by, it could be an in-memory channel, but it could also be Kafka. And so you can completely make your application agnostic of even some of the technologies that it's using for eventing. So you can see, protocol agnostic, so it can be HTTP, AMQP, MQTT, and whatever more. So it's pretty cool spec that, of course, Knative uses. Otherwise, I wouldn't have mentioned it here. So some of the usage patterns of Knative. So you can have a very simple use case where you have an event source. So something creates an event, and you just send that cloud event to a Knative service, and it's going to notice, hey, there's an event coming in. So we can scale based on that. So, but that's a simple use case. There's no kind of back pressure. There's no kind of anything in between to handle whatever these messages are going through. There's no kind of persistence of the messages. So then you have what is called a channel in Knative. So you have, again, an event source, and instead of sending it directly to a consumer, you're going to send it through a channel, a Knative channel, which is then going to send it to whatever subscribers there are for a channel. So if you're familiar with messaging, this is kind of a fairly standard way of doing that, right? But in this case, we're using purely kind of cloud native serverless very lightweight definition, so there's no kind of event buses or heavy brokers or anything that are running. This is just some Kubernetes custom resources. And then you also have a Knative broker, which is a little more, let's say, an intelligent channel where you can filter messages and say, hey, if it's this kind of message, then send it to the subscribers that are filtered to receive this event. And if it's this kind of event, then we can send it to these subscribers. So you can really create a pretty complex eventing mesh of different services. So let's see a small little demo of how that can be done. Keep that in slideshow mode. So I have a function here, this one, and basically it does very complicated stuff. It receives a cloud event and then just echoes it and then creates a cloud event of the same kind. So not very complicated, right? But so this is a very simple kind of Quarkus function that does that. So it uses cloud events to be able to do that. So we can push this to our cluster. So I have, well, I was talking about the OpenShift sandbox. We can actually use it here. So if I start it, so you could just go to developers.redhat.com. That's what I did. And then, so I have just like an empty OpenShift here. And let's push our application to it. So I could use kn func deploy, which would do the build of the application, and then using build packs by default, and then push it to my cluster. But it takes a few minutes, right? Because it needs to use build packs, it needs to create the image, and then download all its Maven dependencies and everything. So I'm going to use Quarkus instead. So I have in my application properties, I have a few properties. So it pushes my image directly to a Quay repository, which I've already done. And so basically what I did was Quarkus push also build, and then -- native. So I created a natively compiled application. So basically this command builds my application, so there's Maven package with GraalVM, so it compiles it down to native, creates a container image, and then pushes it to my registry all at once. So that's what I already did, because we want to save time a little bit. And then I can just do Quarkus deploy knative. And so because I'm already logged into my cluster, that should hopefully push my function to the OpenShift cluster that we just saw. So let's see if the internet, is working. And here we can see our function, and we can see container creating and running. So it's pretty quick, right? So we can see here in the logs, it took 30 milliseconds to start. Well, pretty good, right? And so this is our function that's running. But so it's waiting now for a cloud event to come in. We don't have an event source yet. So I can create a very simple event source using, for example, a ping source. So you have in Knative different kinds of event sources. So you have like a container event source, you have a Kafka source, and in this case, I just have a ping source, which basically just uses like a schedule to send messages over and over again. So in this case, I have it's sending a message test, and then every 2 minutes. So I'm going to apply this. And actually I first need to deploy the broker probably, so because that's what it's going to look for to connect it to my application. So we can do this, through the UIs, because I'm a little bit lazy, and then we'll call it default. And so that creates a broker that's now connected to my application. And now if we push this, and I've already configured it to a broker with the name default, which is exactly what I just created. We can do kubectl, apply, if, and then ping source. Okay, and so now we've created a ping source, which is going to call my function every 2 minutes. So we're going to have to wait a little bit for that to trigger, but so I don't know why I set it for 2 minutes. Actually, I do, because by default, if you deploy a Knative function, it's going to scale down after 60 seconds. So it's going to wait. Is there more traffic going to come in? Then it can handle it immediately. If after 60 seconds there's no traffic coming in, then it's just going to scale down automatically to 0, and then it's going to wait for a request to come in. So I made the ping source to call it every 2 minutes, so it has time to scale back down before the next request comes in. So we'll see that in just a minute, hopefully, if the ping source is doing its job. So you can use this. This is a very simple example, of course, where you just have a very basic ping source that's calling a broker to a function. I could add more subscribers to this broker as well, so you can add some other event sync, or that also is going to listen to these events. But right now I'm just going to use this simple example. So maybe it's been almost 2 minutes. I should have put it like a timer or something, right? So boom, 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 boom. I guess I need a little dance. By the way, I have some Quarkus stickers here, so if anybody's interested in some cool stickers, there's even Quarkus, specifically JCON 2023 stickers. So definitely come grab one. All right, let's see. My patience is very much running out, so if it doesn't start up faster, then I'm gonna just trigger it myself. 3, 2, 1. All right, let's pretend that it sent the request, and then by just calling this, which won't go anywhere, it might scale up. If not, maybe not. Okay. We'll just have to wait a little bit longer. Anyway, so we'll move on to the next thing, and then we can circle back to that. So there's also with serverless, well, we've seen how you need to, how you have events, and so what you typically will have to do is have to integrate different components, right? Which may use different technologies. Maybe you need to do some sort of transformation between different projects. So Apache Camel is a pretty cool project to do that. And so I have a little demo that uses serverless Camel Quarkus to handle some events in different ways, to create a voting app. And then if there's a little bit of Wi-Fi here, maybe you guys can vote as well to scale up the application. So in the meantime, no, this is still not doing anything. All right, so I have another cluster here running my demo application. So I'm going to go to that. I think it's this one. And so, no, it's not this one. Here we go. Is that the same one? Here we go. Nope. It's this one. So let's hit refresh. Uh-oh. The live demos are at work. I think the cluster probably just stopped. Yep. So I'll start up this cluster, which will take a little bit of time. Okay, this is cool. All our fun demos are not working. So the idea behind this demo is you have this UI, and so I'll show a QR code where you can vote for your favorite IDE, IntelliJ or Vim or VS Code or whatever, and then it's going to send an event basically, right? So every time you tap, it's going to create a request, and just the HTTP in this case, to an ingester application that's scaled down to 0 until you send a request. Then it's going to scale up, handle its request, send it to a Kafka topic, and then there's a consumer for this Kafka topic that's going to listen for events coming in on that topic, and then update our database, and then we'll see, what which IDE is the most popular. And then, of course, the IDE reads the database and shows that. So that's the idea behind this thing. Now, my cluster is still starting up, so we'll have to wait until the end of the presentation, and then maybe it'll have started up. We'll see. But so that's the idea behind this. So you can't vote just yet, but that's the architecture of this thing. So here's some free books that you can download that we write at Red Hat. So we have some books on GitOps, but also like if you're a Spring developer, how can you move over to Quarkus and take advantage of these fast startup times and integration with functions as a service with Knative and everything. How to modernize enterprise Java from legacy Java applications to more modern architectures and everything. And then of course I have to advertise the sandbox a little bit that I just showed. So here's that, and I'll link the slides in just a little bit. This is the source code for the Knative function that I was just showing. So if you want to try it out with that ping source, feel free to check it out. And then here's the source code for that Camel Quarkus folder. But what I'll do is here's the QR code that takes you to the slides, I hope, if the QR code worked. And then you can download the slides, and then you have all those links that I showed before. And then, yeah, if you want to keep up to date with all this cool Quarkus and Knative stuff, I try to post, like my findings and what I'm doing and everything on, the usual channels, Twitter and on YouTube and on LinkedIn. And after this session, no, actually at 4, Daniel here, the blonde guy, he's wearing the same t-shirt as I am, and he's doing a session on auto-scaling with Knative and Kada together, so that's a really cool session, so definitely follow that one. And then let's go see if our cluster has started yet. I suspect it's going to take a little longer than that. In the meantime, let's see if we can make our ping source work. So I'm going to change it to higher frequency, and we can apply that. And now we'll see if it's going to be a little faster to wake up. If not, we're just going to give up on it because maybe I'm missing something. So here's our function, which is scaled to 0 right now. And you can see it's auto-scaled to 0 until a request comes in. If not, we can try to add another event source. So this is the OpenShift UI. You can do kind of the similar things with Knative. You don't have maybe the exact same UI, but this is just kind of an abstraction layer for it. So we can say, we can create a ping source. We can do a binding between, deployments and stateful. So something that happens in Kubernetes that then triggers an event and stuff like that. So let's see one more time if we can create a ping source here. Oh, okay. I can only do it through by applying a YAML, which is kind of interesting. Anyway, creator. Yeah. So you're just going to have to believe me then that this totally works. Okay, let's see if this one has started up in the meantime. So this is looking good. Okay, so here's the other application that I have that I had prepared, right? So we have a Kafka cluster running here. I created a topic. We have a Postgres database where our results are stored. And you can see here, our processor has this blue circle, which means that it's actually running. It has one pod running. And then we have the UI here, which doesn't have that blue circle, and the ingester here that doesn't have that blue circle, because there's no request coming in right now. So if I create a request, I can just go to the URL, and then we can see container creating and running. And so basically, because I created a request to this application, we can see now that these pods are running, and then we can see in a little bit that if I don't send any more requests, that it'll scale back down to 0. So it'll terminate the containers and then wait again for more traffic. So let's see if that happens in a few seconds. And in the meantime, I'll show you our votes. So right now, well, there's already some votes in there. That's okay. In the meantime, you can see that our pods are terminating. So again, we're going back to no resources used. So let's let you vote. So maybe I'll go to the database. So I'm just going to log in to the pod. We'll go to the terminal. Let's see if I remember PSQL vote DB, and then update vote set counter equals 0. Let's see if that works. Okay. So now if we go back to our votes, okay, we have 0 votes for all our IDEs. So I'm gonna show you the QR code, and then you can vote with me. Okay, so we'll go back to that slide. Okay, so I want to see what your favorite IDE is, people. So, and by doing this, you'll get a really crappy UI because I'm terrible at creating a UI. And then vote for your favorite IDE, and don't be shy. You can vote as many times as you want. And so the more you vote, the more pods we're going to be creating. So let everybody scan real quick, and okay. So let's go back to our application here, and I can see that votes are coming in pretty rapidly. That's good. So keep tapping on that. And then in the meantime, we can see here that our components are scaling up, right? So we can see we have multiple UI pods and multiple pods here. We have 14 that we're running, so there's a bunch of requests coming in, and it's trying to handle all that traffic because I basically set the Knative service to say every concurrent request create more pods. So it's a little ridiculous, but for the demo purposes, this is perfect. So you can see, I can see you guys are tapping away, and we're creating all these pods to handle the traffic, and we can see here that wow, IntelliJ is the most popular with 1,700. So somebody's clicking really good here. So that's some example of how to use serverless with containers. So in this case, I'm not using functions. I'm using actual regular containers running camel Quarkus in this case to scale up based on demand. So good job for the IntelliJ users. You guys are, well, either the best tappers or there's more of you in here. I don't know which one it is. But yeah, so that's a short introduction to Quarkus and Knative. So, if you have any questions, I have 3 more minutes. If not, I'll be here for a little bit longer if you're on the shyer side. And again, I have stickers, and if we run out, I have more stickers, so don't worry. Any questions? Everybody's shy? I'm just gonna stand here for like 3 minutes, like waiting patiently for there. Yeah, what about licensing for Quarkus? So Quarkus itself is, just open source, so you can use the upstream version completely for free. There's no license. If you want support, well, you can pay for it. No. If you're using the upstream version, so from Quarkus, you can create issues on GitHub. They're very good at responding. If you want enterprise support, you can get that through Red Hat. So if you're an OpenShift customer, you're running Quarkus on OpenShift, you actually get free support for Quarkus. If not, you can get a subscription for support with Quarkus so that you have SLAs and all that stuff too. Yeah. Yes? So we actually have a project which is called Mandrill, which is a subset of Graal VM. So this is a collaboration between Oracle and Red Hat. And so Mandrill is a completely license-free way to do native compilation of Java applications. So it doesn't have all the capability, well, it doesn't have the support for all the other languages and everything that Graal VM has. But yeah, so if you use Quarkus, and you do a native build and you don't have GraalVM on your local machine, actually what it does is it notices, hey, you don't have GraalVM, so it pulls down a container image, which is a mandrel container image, and will do the native build in a container on your local machine or in your pipeline or wherever. So yeah, so no license needed there too either. Pretty nice, huh? More questions? All right, thank you. And yeah, if you have any, kind of more private questions or anything, come down. And yeah, if you want stickers as well, come grab them. And then thank you and have a nice day.